Hello friends, in the last lecture we had discussed the effect, that is stress developed due to axial load and eccentric axial load. So in the next video lecture we'll take some examples of normal stresses developed due to axial load. The example states that a hollow steel tube with an inside diameter of 100 mm must carry a tensile load of 400 kilonewtons. Determine the outside diameter of the tube if the stress is limited to 120 meganewton per meter square. Let's start off with the solution, students. P is equal to sigma A, where P is equal to 400 kilonewtons, which is nothing but 4 lakh newtons. Sigma is equal to 120 megapascal. Area is equal to 1 upon 4 d square minus 1 upon 4 pi into 100 square, which is nothing but 1 upon 4 pi in the bracket d square minus 10,000. Thus, 4 lakh is equal to 120 in the bracket 1 upon 4 pi d square minus 10,000. Therefore, 4 lakh is equal to 30 pi d square minus 3 lakh pi. D square is equal to 4 lakh minus 3 lakh pi. The whole upon 30 pi. Therefore, on calculating, we get the answer of D is equal to 119.35 millimeter. And this is our answer. Hence, we can say that the diameter is equal to 119.35 millimeter. In the next example, it states that the homogeneous bar shown in the figure is supported by a smooth pin at C and a cable that runs from A to B around the smooth peg at D. Find the stresses in the cable if its diameter is 0.6 centimeters and the bar weighs 6 kilonewton. Let's get into the solution, students. First, we'll draw the free body diagram. Once we are drawn with the free body diagram, we'll go for the moment at point C. We know that summation of moment at point C is equal to 0. Hence, we can say that 5t plus 10 in the bracket 3 upon root 34t is equal to 5 into 6000. Let's write it down. On solving this answer, we get the answer of t is equal to 2957.13 lb. Hence, we can understand that the stress in this answer is T is equal to 2957.13 lb. Now, going ahead, when we go for the formula of T is equal to sigma A, we can say that T is equal to sigma A. Next, we know that the tension is 2957.13. We know that T is equal to sigma A. The value of T is found out to be as 2957.13. The load here is to be found. Hence, we can write that 2957.13 is equal to sigma in the bracket 1 upon 4 pi 0.6 the whole square, where area is equal to 1 upon 4 pi in the bracket 0.6 the whole square. On finding out the answer of sigma, we get the answer of sigma is equal to 10,458.72 psi. Hence, sigma is equal to 10,000 458.72 psi. This is the answer, students, for this solution. Let's go for the third question, students. The question says, determine the largest weight W that can be supported by two wires shown in the figure. The stress in either wire is not to exceed 30 ton per centimeter square. The cross-sectional areas of the wires AB and AC are 0.4 cm square and 0.5 cm squares respectively. Let's go for the solution. First, let us draw the free body diagram of joint A. Next, we draw the free body diagram of knot A. So here, students, we have shown the free body diagram of knot A. Now let's go for the solution, students. We know that the force polygon of the forces of knot A can be drawn as follows. Now, for the wire AB, by sine law from the force polygon, we can say that TAB, that is tension in the wire AB, is equal to TAB upon sine 40, which is equal to W upon sine 80. So we have done this by using the sine law. So let's make a mention about this using the sine law. Now, if we go for the solution part, we know that TAB is equal to 0.652 W, and we can also say that sigma AB into A is equal to 0.6527 W. We know that sigma AB is equal to 30 and A is nothing but 0.4. Here A is for the area of AB. We know that area of AB is equal to 0.4. Hence, 330 into 0.4 is equal to 0.652 into W. If we find out the answer of W on calculating the values, we get W is equal to 18.4 KIPS. This is the answer for the question. Next, we go for the question number 4. In this question, it states that a rod of length having uniform cross-section area A is subjected to a tensile force P as shown in the figure below. If the Young's modulus of the material varies linearly from E1 to E2 along the length of the rod, the normal stresses developed at the section SS is. The options have been given in this question. We have been given 4 options. The option A is P upon A, option B is P in the bracket E1 minus E2 the whole upon A in the bracket E1 plus E2, option C is P E2 the whole upon A into E1, and option D is P into E1 the whole upon A into E2. Let's go for the solution part. The answer is A because the stress only depends on load and area of cross section. Let's write it down. In this lecture, we took some examples of normal stress. In the next lecture, we will take some examples of stress developed due to eccentric axial loading. That's all for today, students. Thank you very much.